Okay, guys, welcome back to Remote Learning. Good to speak to you all. It's been a couple of weeks. Hope you had a good time off. Enjoyed the chocolate. I know I did. The sun's also out, so could be worse. And also, you're back doing some maths, which is really exciting. And I'm pleased to be here speaking to you again. Right, just a couple of things before we start with the lesson. Now, a few of you still need to complete a fair bit of work actually that I set on Dr. Frost over the holidays. That work hasn't gone away, and I will be sending out a reminder every week. You need to complete that. It's 6 papers in total. Some of you have. It's really important you do that because from today we're actually going to be moving on to the further maths material, which is really exciting. So do that. And upload your workings. Amelia's done a really good job here. Paper workings, and she's got all 6 papers here with the workings, which look really, really nice. So that's what I expect you to see. Create a page, please, like that. Now, each lesson from now, I'm going to create a page for you, like I've done in Albies. You should all have a page that says 23rd of April 20 complex numbers. And please, for this lesson, upload all your work onto this page only. That's really important. It makes it really easy for you to keep your notes nice and neat. And then next lesson, I'll create a new page for you to do that. Okay. Right, let's get started straight into the lesson. And we're going to start with a starter. And this is AS material, so it should be quite straightforward for you now. Okay, so I'm going to disappear as well, so you won't see me again. But I'm going to. Sorry. Okay, you've got 5 minutes. Off you go. Okay, that's about time, guys. Right, here are the answers. You can mark your own work, please, as you go. So question 1, it was the maximum point occurs. You differentiate it equal to 0. It was V was 1,736. This one, integrate. 6 seconds there. Just take your time if you do. If you don't get these, and then they're neither parallel nor perpendicular. Now I appreciate you. We may have even done this one before, but I couldn't remember doing it. So it's good practice anyway. Right, okay, so moving on. Now, you should be in your exercise books. Hopefully, if you run out of space, please just do it on paper and keep it all nice and neat. You're going to upload it to OneNote anyway, so it'll be stored on there. But we are moving on to further maths, which is really exciting. Now, the book we're going to be using is... so the book we're going to be using is this one here. This one. So that book there. Now you've all got access to it on your. You should have access. To that on the online system. I think even a few of you might have sneaked in a hard copy. But if you struggle to use the online book, you need to let me know because that's the book we're going to be using, and a lot of the questions I set are going to be from that book. So it's the Pure Book 1, and that's what you're going to be doing with me and Miss Chobasic soon. She'll be moving on to that. Okay, right, let's start with the lesson. So, date is the 24th, is it? No, 23rd, sorry. 23rd today. And it's a super cool lesson. It is on complex numbers. Okay, we're entering a different dimension in the maths world, which is really, really exciting and a bit weird. So, just to warn you, your brain will struggle to deal with this. I know mine still does, to be honest. Okay, now I'm going to start with one of the most amazing equations in maths. Okay, e to the pi I equals -1. Now this, it really is the beautiful maths equation. Mathematicians have this tattooed all over the place. And it really is amazing because it links 3 completely weird things together to come up with a very simple answer. Now we know what E is. E is 2.71, it goes on forever. It's to do with exponentials, which is in the news a lot today because of COVID-19. Pi we know is, again, it's an irrational number. That's what's weird about this equation, 3.14. Etc. Now I is even weirder. So I is what we're going to look at today, but I is the square root of -1. Now some of you may have seen that, but that really is weird. If you think of a number times itself gives you -1, that's basically what sort of I is, and that's really, really weird to get your head around. Now that equation there, it's not just a beautiful maths equation. There are some practical uses of it. And complex numbers, you may think, well, what's the point of complex numbers? I used to think this at school, and I was never told an answer. And then I went to university and I did a whole module on complex numbers when I was doing engineering, because it comes up in engineering time and time again, and it comes up in electronics. It comes up in fluid design and fluid mechanics. It's basically, it's used a lot in these functions for when you're considering flow rates or anything that's sort of waves. So electronic circuits, they're sort of in waves. And this formula above, that specifically may not be used, but the principles behind it are used. So you may think, what's the point of learning this new dimension of maths? Which is exactly what I did. But then I did find out it had many uses, and we're going to look at some of the uses, maybe not today, because we need to get a grasp on how to use these complex numbers, but certainly I will be showing you some applications of them as we progress through this chapter. I think that's very important. Right, now let's go straight. So we've got imaginary numbers, which are slightly different to complex numbers. So imaginary numbers, these are purely imaginary. So this is our sort of unit. I is the square root of -1. Now, anyone who goes on to do engineering or physics at university, you may have some lecturers that call it J. which is very annoying. In maths, we only really say I, but when you go to university, in the lecturer just puts J up, they might be talking about I, so just be aware of that. You won't see that in this course though, J, but it does come up. So, and an e.g., you might get a complex number that's something like 9i. That would be an example. And in sort of, I suppose, to visualize that, that would be 9 times the square root of -1. That's all that is. Now, you can't possibly try and imagine what that number represents because square root of -1 doesn't really mean anything on itself. Okay, so that's what imaginary numbers are. Imaginary numbers are purely just the imaginary part, hence why it's called I. Complex numbers are slightly different, so you do need to know the difference between them. And a complex number is slightly different to an imaginary number because it has two parts. A complex number is often referred to as Z. Z is often denoted as a complex number. And so a complex number there, don't know what that is yet, is equal to a real part plus an imaginary part. So this is real plus an imaginary. Okay, so that's all a complex number is. Now in reality, that's probably made it sound a bit more complicated. So something like 3 plus 9i is a complex number. Okay, so that's all it is. It's just a real part plus an imaginary part. Now these come up much more in sort of real life, which is hence why the chapter's called complex numbers. Imaginary numbers on their own are not particularly useful, but when you make them a complex number, they then become you do see them in practice. Okay. Right, we're going to look at a few examples on how to manipulate these complex numbers. So examples. So find, let's just do example 1. Find in terms of I root minus 28 and root minus 200. Okay, now I works the same, so the standard surd rules apply. Okay, so standard surd rules apply here, which means I can split this up. So I can split this up into root minus 1, root 28. Okay, now at this point I can still split it up even further. I've got root minus 1. I can split the root 28 up into, what's the biggest square number that goes into that? Well, 4 does, doesn't it? Root 4, root 7. Now, square root of 4 is 2. That is I. So I'm going to get 2 root 7 I. Okay, that is going to be my answer for that particular question. Now, you can practice in the calculator. I'll show you in another lesson how to use that. But there is a complex mode that will simplify these for you, and I will show you those at a later date. Maybe have a quick go at this one. Quick pause the video, see what you get for root minus 200. Okay, I'll give you a few seconds on that. Do pause it. It would work the same way as this. Root minus 1, root 200, root minus 1, root 100, root 2. So that's going to be 10i times root 2. And we just tidy that up a little bit by putting 10 root 2i. Okay, that would be our solution to that one in a simplest form. Okay, so i's just work the same as surds. Nothing new there. Okay, I suppose example 2 is simplifying. Now this is even easier if I'm honest. Simplifying. So let's have a look at. So simplify 2. 5 minus 1 b, let's do sort of 10 plus 6i over 2. You might get c 2 minus 5i 3 2 4i. Okay, these same rules apply, nothing new in maths here. So multiply out the brackets for this first one. 10 minus 16i. Okay, straight away, it's nothing too hard there. Second one, again, you simplify this fraction as usual. Divide them both by 2. You're going to get 5 plus 3i. Simple as that. This one here, again, not much different. 5 minus 2 minus 5i. I'm going to just multiply this out. Minus 6, and then be careful with the double negative. Plus 12i, and then I just group like terms. So I'm going to get minus 4 plus 7i. There you go. We tend to write it in this order. So it's generally real plus imaginary. Okay, that's just notation. We don't generally put the real part first and then the imaginary part second, so don't fall into that trap. Okay, so hopefully that's not too bad. That's really, I mean, I reckon I could have taught my year 9 class up to this point. And you were all very good. Right, we're moving on to solving equations. Again, not too difficult this, because now I've introduced a new one. I've got 2 examples. An easy one here. Let's say z squared plus 9 equals 0. Okay, now for this example you solve it as you normally would, minus 9 from both sides. And at this point, in the past, you would have said to me, no, can't do that, sir. You can't square root a negative. Well, you can square root a negative in the complex plane, which is where we're at today. There's not going to be real solutions to this. There are going to be some complex or imaginary solutions. So if I square root both sides, which is fine, I've done that. I got to be careful. It is still plus or minus here. So then I can use normal surd rules, plus or minus root 9, root minus 1. I've just split that up. And that means z is going to be plus or minus 3i. And your calculator will actually solve this, the formula mode. It will give you the complex solution so you can check your answer. Okay, EG2, that's a nice, EG2 slightly more advanced. Z squared plus 6. Z plus 25 equals 0. Remember, Z's often the letter we use for imaginary numbers, not exclusively, but it's like we use X in the real domain. Z's often used in the imaginary or complex plane. Okay, so if I'm solving this, I mean, your first step would probably be, can you factorize it? And I know immediately I probably can't factorize it, because you can't factorize ones easily with complex solutions. So I'm not going to factorize. So I've now got 2 options really. I'm going to sort of talk through each one. You could either complete the square, which is a personal favourite of mine. Really nice way of doing it. So option 1, I suppose, well, you could either complete the square. Now to do that, you just z plus 3 squared. I'm going to have to minus 9 and then plus the 25 equals 0. So I've got z plus 3 squared, that's going to end up equaling minus 16. Z plus 3 equals plus or minus the square root of minus 16. So z is equal to, that's going to end up being plus or minus 4i. You can have a go yourself at that one. So my final answer will be z is equal to minus 3 plus or minus 4i. Okay, the 2 answers there. I should probably write that out as separate answers just to make sure I'm clear, or minus. So just remember to write them out separately. The other option is I could have simply used the formula. Could have used the quadratic formula here in the same way. So z is equal to minus b plus or minus the square root of b squared minus 4ac. So a is 1. C is 25 over 2a, 2. And if you've worked that through, you will end up with the same answers. It's your choice what method you use. It's your personal preference. I probably prefer completing the square. I think that's quite nice. But when you've got a number, you might have a number in front there. And then completing the square may not be the best option because it's not as easy to complete the square, and the formula might just be the simpler way. So don't just stick to one. You might want to just rotate. Right. Okay. That's all the knowledge today. I haven't started. I know it's a new topic, so it might seem a bit crazy, but it's actually, I think I've said this before. The further maths topics you'll find, and maybe some of them are not as hard as some of the A-level topics. So I think you should be okay with that. Now, your homework, well, your classwork / homework, because I want you to finish this, and you should really finish it in the designated time. It's from that new book, so it's the book 1. So it's called Core Maths. The one I highlighted earlier, the Core Maths book 1. Okay, and I want you to do exercise 1A. Exercise 1A, but just do so for questions 1 to 3, do alternate questions. So for instance, A, C, E. Okay, and then you do the whole of question 4 to 8. They're not long questions. And then exercise 1B as well. Again, question 1 to 4, I want you to do alternate. So A, C, E, etc. And then the whole of question 5 and question 6. It's not. It might seem like a lot, but that's not that much. They're quite quick questions to do. Okay, that's it for today, guys. Do the work. If you've got any issues, I'll be on the Teams website during our lesson time. So if you wanna log on there and have a chat, or just if you've got any queries, do let me know. I'll just add to this. Upload to OneNote, and it's really important, the correct page, please. Okay, the correct page, that's really important for me when I'm looking at the work. It saves me a massive amount of time. Okay, right, that's it for today. I'll check in with you tomorrow, and speak soon.